Oh, maurieo. Worksheets LS 046A and B, bearing close 001. In this video, I'm going to take a look at a worksheet regarding a bearing close. One of my students has asked me to have a look at it because they don't quite haven't quite been able to follow how we adjust the bearings. So I'm going to take a look at the whole worksheet and we'll just see where it goes from there. So we need to perhaps get to the end of the slideshow, and let's go to the large screen and have a look at the worksheet. So the worksheet comes in two parts. First of all, we have here a little piece of the field note. So this is sort of part of a field note. All of the readings have been done. This is the final one. So it's possibly even what we might call a bearing close sheet. And we have over here in a diagram showing there, and a few steps on what to do. Close the bearings, determine the adjustment, apply the adjustment, round the bearings to the nearest 10 seconds, record the final bearings and distances on the diagram, and then create a Travis sheet for the exercise and close that up. The little table down here. If we go down here, here's the Travis sheet for the exercise. Now, just taking a look at this, first of all, we've got a coordinate here at iron tube 3, DPS 30726. And we note that it's a closed Travis. There's one coordinate and there's one existing bearing here. And these two marks here are shown. You see they've got a little black circle in there, which indicates that they're existing old marks, and this is the data that we know, the distance 111.39. So we're going to, pretty much we know that information, we're going to hold that information. I've just, for simplicity, just got one bearing here. So we're going to close around this way here. And so we look here at our field note. So first of all, we're at iron tube 3, where we observed down to iron tube 4, which is our known bearing, which was set 2240930, and there's the distance. And then we're observing a new bearing down to here, 1442339, 76.51. And then this is at iron tube 1. We're going to set as a back bearing 3242339, add on 180, and then we observe a new bearing to iron tube 2, which is 1920819 for 118.45 meters. Then we're at iron tube 2. We set as our back bearing or back bearing IT2 to IT1, and that'll be 180 different to that, 120819. And that gives us a bearing, a forward bearing, up to iron tube 4 of 315.1511, 138.12. Very well. And then we set up at iron tube 4. Now we set our back bearing at the one we brought forward, this one here. So 180 different to that, which is 315.1511. And we observe on to iron tube 3, and we get 440910. But hang on a minute, that should be 440930. So we've got 20 seconds out there, and that is the misclose. That's the bearing misclose. So what I'm going to do now is have a look at the actual answers to this here. So I'm going to go, this is the actual thing there. I'm going to go back from there and let's go to the answers where we've got this all filled out. and we're going to just turn that through, hopefully 180 degrees. All right, so all of this, we come right through to the end, and we can see that we've got 440910. So the first thing we do is we say, well, that should be 440930. That means we've got to add 20 seconds onto there to give us there. So we get that 20 seconds from there, the bearing must close. Right here, none of this other writing is that comes later. So first is the 20 seconds there, and that's our bearing must close. Now we look at the number of setups. We set up here at 1, 2, 3, 4 setups. So there's 4 stations. 20 divided by 4 is 5. So we've got 20 seconds. We want to distribute that evenly back through the stations, and we work out that that's 4 stations, 5 seconds per station. So we've got 20 here to make that true. So we take 5 seconds off the 20, that'll give us 15. And we apply the 15 to this line here, iron tube 4 to iron tube 2. Now when we go up to iron tube 2, okay, iron tube 4 to iron tube 2, there's a bit of an error there. That should actually be iron tube 4 in there, that 315. So that there should be iron tube 4. Never mind, we can deal with that. So it's the same bearing. So that's going to have the same 15 seconds applied to it. So that would make that 315, 15, 26. So it's 135. And then we apply another 5 seconds. So that becomes, that's 15, that'll be 10. And you can see similarly that that's 1208. That's the same line, it's just each end. So, you know, you can't have a different bearing from each end of the line, they're the same line. So, yes, so that's 10 seconds. So at this station here, another 5. 10 minus 5 is 5. And again, that line there is the same as this one here, just a different end, 180 different. So that's our 5 there, that goes up to there. And then we apply another 5, which makes this 0. And of course, this can't change because that's the one we started with. So now we've got all of our bearings in through there sorted. And the next thing we're going to do, or we want to do, is to round them. And I've said round them to the nearest 10 seconds. They're all reasonably long lengths of line. So let's round them to the nearest 10 seconds. And we get 2240930, 1442340, that's 180 different. So that'll be the same. 1920830, 3151530, and then 440930, of course, which is what we started with, and we've got all our distances. Now, so this is like, I've said this is usually the field note, and when we do a field note, we usually have a field diagram. So, as you can see, reading bearings and distances off here, particularly, you know, can be a little bit tricky. Which one do we use? You know, is it that one? Is it that one? You know, there's a few little corrections and things like that. So the best thing to do, and what I insist you do, to have a complete field note, is that you write your final bearings on the diagram. Okay, so we've got 44, 23, 40. Carefully write them on, the rounded ones, 1920830. And usually in the direction that you're going to run out the traverse. So in this case, we're going to go down here, and down here. And then, well, that one's already there. So we can't write 440930 in there, but we can easily take 180 off. So we write the final ones down there. 144, 23, 40, 76.51, 1920830, 118.45, 315, 15, 30, and 138.12, and that one there as it is. Now what that means is that it then becomes very easy to fill in your Travis sheet or any calculations, because you just go straight to the diagram and write everything down as it is on the diagrams in there. So the next step here, oh, I've got a bit too small there now. The next step here is to fill in our Travis sheet here. So I'm going to, oh, that's all right there. So we're always going to start here at 705 362.45, and that gets written in there. That's iron tube, and these must be filled out completely. You don't leave any bits out. So iron tube 2 DPS there is filled in there. And remember that the top line is always blank. That's the coordinate there, 705 362.45 345 263.37. Now the top line is always blank, because the way the Travis sheet works is you go from there to there, and that's the bearing and distance from there to there. From there to there, that's the bearing and distance. From there to there, that's the bearing and distance. From there to there, you guessed it, that is the bearing and distance. Okay. Now, that's all written in there, all of those bearings and distances. So I think we can forget about the diagram now. We've got all the information that we want off that. You can go up there. So now we can start working on this. Now this is a pretty standard sort of procedure here. And what we do is we take the cosine, that's the cosine of the bearing, 144.2340, the cosine of the bearing, multiply it by the distance, and whatever the sine is, it goes there. Then we take the sine of the bearing, multiply it by the distance, and its sine goes there, right in there. Okay, that's where that goes. So what I can't, because of the nature of this, the functionality that we've got here, I'm using this through Moodle, I can't write on here. But what I can do is I can not do that. I can just drop that out of the way. I can get my little calculator out just to do the first one anyway. My little FX82, just to show you what's going on here. So what I can do is go cosine 144 degrees, 23 minutes and 40 seconds, close the bracket, times 76.51 equals negative 62.21. Now I'm going to be working to 2 decimal places here. Shift mode, fix 2, minus 62.21. And then I can do sine 144 degrees, 23 minutes and 40 seconds, 40 seconds, close the brackets, times 76.51 equals 44.54. So that we go through and do that for all 4 of those, and we add them up. And lo and behold, in this area here, we get 0, 0. So there's no adjustment needed. And in this area here, we get 01 plus 01. So we need to subtract 01. Now we could use the Bowditch adjustment as I have, but it's just 01. And so typically we put the most error will be in the longest line, 138. So I'm just going to put that negative 01 in there, because this is positive, this is negative. That's going to go in there, and that's going to give us our adjustment for that side. So those two there are equal and opposite, equal and opposite. Okay, so now we work on our coordinates. We do our northings first. 705,362.45 minus 62.21, and there's no adjustment. It gives us that value there. Minus 115.80, no adjustment. That's going to give us that value there. Okay, plus 98.1, give us that value, and plus 79.91 gives us that value there, which should always equal, if we've got a loop closed traverse, what we started with, and it does. So that's a good arithmetic check. Everything's pretty good. And then we do the same thing for the eastings down here, check that there, except here we have an adjustment. So here we're going to go that value there minus that will give us that value there, and that'll include the adjustment, and we get there. Now if we don't get agreement there, you've gone wrong, you're doing it wrong. You've got to start again till you do. If you don't get agreement there, start again till you do. So that gives us there. Now we want to look at our misclose, and we've got our total here. Our misclose is actually 01 because we can't draw any little triangles, so our misclose is 01. So as a representative fraction, we go 444.47 divided by 0.01, and that'll give us 1 to 44,447, which is a very good misclose, a very good fraction. That's a very tight traverse, not much error there. And then we need to know the direction of the thing. Well, we can see here that the direction is 01. When we get there, we've got to go 01 east. 01 east, so that's 0.1, and east, it's due east because it's all 0, is 90 degrees. So there's that one all done. Yep, that's bearing close worksheet 001 completed. And so with that in mind, I think we've pretty much finished our worksheet, and we've got it all sorted out. I just want to really appreciate someone taking the time to ask me how to do this and give me the opportunity to prepare or go through this worksheet. It's really good feedback. It tells me where things are. So thanks for that. I hope it's been helpful. If you have more questions, you could always have a look in the YouTube comments will get me, or you've got my email, and you can email me, and I'll see if I can do something further to clarify the situation. So that brings this video to a close. Cheers, and see you.